Hello, today I'm here to talk to you about how LiveRecorder for Java can be used with an example Spring Boot environment to track issues across microservices. Let's start by having a look at this Spring Boot Petclinic example. As you can see, we can have a look at the list of owners and we can look at the details for some of these owners. For this example, we know that there are some bugs which have been introduced into this application. So we're going to start recording now so that we're able to capture the execution of at least two of the key microservices. As you can see, the first ones are still working, however there's been a problem which has been introduced with Peter and Maria further down the list. As you can see, in both cases, the owner details as well as the pet information fails to load. So again, we can use the endpoints added when LiveRecorder for Java was integrated into these applications in order to save the recordings we've just been generating. With the recordings from the two microservices downloaded now, we will use LiveRecorder for Java's replay component and open them in IntelliJ in order to explore what happened. You can see this script has launched two copies of the replay component, one for each recording. One is listening on port 9001 and the other is listening on port 9002. And then we launched two copies of IntelliJ in order to be able to debug both of these recordings. As the workspace is already set up in IntelliJ, all I need to do is press the debug button in order to connect IntelliJ to the LiveRecorder for Java replay component. As we haven't set any breakpoints in IntelliJ, the recordings will run to the end and then we will start exploring from there. When we built this microservice example, we enabled Sleuth. Sleuth allows you to track all of the interactions between the microservices across the network, and then we can use Zipkin in order to look at the individual messages that were sent back and forth. As you can see in Zipkin, once we sort the transactions chronologically, you can see all of the interactions between the microservices, including the ones at the end where we save the recordings. We know some of the older transactions completed perfectly. However, the more recent ones we had issues with, especially the one here which seems to have taken over half a second. So let's have a look at that one. When we look at the specifics of this transaction, we can see it was requesting the details for owner 5. And if we go back here, we can see that the fifth owner was indeed Peter, and we can even see the URL in the bottom left. If we go back to Zipkin, we can find the trace ID and we can copy that. This transaction was from the API gateway to the customer service. So let's go to the customer service IntelliJ session. Here we can use the log jump button, which allows us to jump to a specific point in the recording using a timestamp BB count, or in this instance, a trace ID. The tool is now searching through the recording to find where the transaction was received, requesting details for owner 5. And here we are at the function that actually handles that specific endpoint at the point where that transaction was received. So from this point we can start stepping forwards through the recording. And we can see that owner 5 was correctly identified with their details acquired from the repository. And so if we step forward from this point, we can see we quickly hit one of the first injected errors in this example. The code is checking if the first name of the owner is Peter, and therefore it throws an exception for Peter McTavish. So we've identified that issue. Let's go back to Zipkin and find the next transaction which also failed. If you remember, we were looking at Maria's details. And so here you can see we were looking for owner 8, and we can then go back and confirm that Maria is in fact owner 8. Again, the URL is in the bottom left. So again, let's find the span ID and we will copy this. And back to IntelliJ, we can again use the log jump to jump to the point where this transaction was received. As before, at the start of this method, this time we're looking for owner ID 8. Again, we'll step forward and we'll confirm that Maria's details were in fact loaded. And this time, because the first name is Maria, rather than throw an exception, we're just going to return an empty result. So that explains the two injected errors into this code. Let's do some more exploration. If we set a breakpoint at line 67, we can use resume back to go back and see what happened at previous points when we hit this line. And here we are for the previous transaction when we were looking for Peter's details. And before that, the transaction looking for owner 3, Eduardo's details. Here we can try the step across back feature. This feature is quite powerful. It identifies a transaction that we just received based on where we are in the current recording. It then looks for other instances of IntelliJ running replays of other services, and it will go back into those recordings and identify where this transaction was issued. And here we are in the API Gateway IntelliJ session, which has been brought to the point where it is about to issue this transaction. As you can see, it is looking for owner ID 3. So let's put a breakpoint at the start of this rather elaborate line of code, and we will go back. And we can see at this point we are issuing a transaction looking for the details for owner ID 2. In this instance, the transaction is going in the opposite direction. So instead of step back across, we're going to use step across in order to take the other IntelliJ session to the point where this transaction is received by the customer's service. And here we are back in this method at line 65, this time when the transaction was received looking for owner ID 2. And if we continue forward to our breakpoint, we will see that this customer's information is loaded correctly. And as Betty is not one of the relevant names to cause the injected errors, this data is returned correctly for the original transaction. Hopefully this has shown you how some of the advanced features of our LiveRecorder for Java tooling and the IntelliJ plugin allow you to navigate and diagnose issues in recordings based on larger, more complicated applications, including microservice applications. Thank you very much for your time.